Hello guys, welcome to my YouTube channel. In this video, I'm gonna show you what it takes to build a Nixie Clock.
And by the way, don't kill me if my English is not sufficiently fluent. I'm still ramping up things, so this is one of my first YouTube videos. So let's see. And by the way, if you like the type of content that I do, please subscribe to my channel.
Okay, so what is actually a Nixie tube? What it's made of and how it actually generates this light that they are very well known for. This is the sketch of the electrodes inside of a Nixie tube. I have drawn the anode and the 10 cathodes electrodes. This is just to have a clear view. So the anode is at the positive rail and the cathodes are the negative or ground. Okay, so this is the basic diagram of how a Nixie tube is controlled. We have our positive power supply, a resistor, and the two electrodes of the tube, the anode and the cathode, and a switch. Now, the way how this operates, once we have a voltage potential between the electrodes, because of the gas inside the balloon, it will start forming ions, and these ions are attracted by the cathode electrode, and this causes it to glow. This is where the glow comes from. And this is how it looks like in the real life. You can see the nice glow. Now, concerning this video, I thought that it will be better to split this construction into several episodes because I don't want to get bored or oversaturated from too many information. So this video probably would not be so long, but just to be aware that more videos will follow up on this subject. Okay, before I show you the schematics and the PCB, this is the general diagram. So let's see the schematics. I will show you quickly the main blocks that I've built for this clock. Here we have the USB-C connector. This is the IC that is responsible for negotiating power delivery with our USB power supply. The voltage is stepped up to 9 volts through the power delivery protocol. Then this 9 volts will feed our 5 volt step down converter. This is used for the LED drivers. From these 5 volts we take another low drop regulator, an LDO, to provide us 3.3 volts for the microcontroller. Here we have the boost converter. This is responsible for generating the high voltage for the Nixie tubes. This is also supplied from the 9 volts that is coming through the USB-C connection. Okay, let's go to the microcontroller section. Here we have more ICs, not just the microcontroller. So here there are the ports for various signals. This is the main Nixie tube driver. It's the only one. It has a lot of input. I think, yeah, it can drive up to 64 channels. It's connected through SPI with the microcontroller. Also in between them there is a level shifter, because the tube driver is working at a 5 volt logic level and the microcontroller is working at a 3.3. Up here we have the LED driver. This is responsible for driving all the RGB LEDs. This is a 3 color channel. And on the next page we have the LEDs and the tube assembly. I just made them separate sheets to have a more clear view through the schematics. These 4 here are the indicator tubes. These will tick at 1 second interval, on and off. It gives a nice look to the watch. So yeah, this is pretty much all regarding the schematic. I will show you in the next episodes more details concerning each block, because there is a lot to share with you. This is the PCB file for the Nixie clock. It's a 4-layer PCB. Here there is this strange shape because I've decided to place the boost converter here, so I just have a little cut here to isolate the PCB. Basically I will end up with 2 PCBs. Now this will stack on top of this one. I've chosen this solution to avoid the heat coming from the boost converter. Now this boost converter dissipates some heat, and I wanted to keep this heat away from the main PCB, because on long term the PCB will heat up quite significantly, and this will cause some temperature drifts, and this will affect our clock precision. I will show you more in the video where I will explain to you how to calibrate, how the real-time clock module is calibrated and tweaked. This is because we need to have a precise timing to avoid erroring, but I will show you later on. Be patient, please. Thank you guys for watching. If you enjoyed this video, like and subscribe. See you next time.